High-tendency state standard is to verify experimentally properties of rotations, reflections, and translations. Lines are taken to lines and line segments to line segments of the same length. Angles are taken to angles of the same measure. Parallel lines are taken to parallel lines. Another standard for today's lesson is to describe the effect of dilations, translations, rotations, and reflections on two-dimensional figures using coordinates. Your lesson objective that you need to write down: I can find the coordinates of a figure after a translation using an algebraic rule. So you'll need to pause the video and write that down. All right, so we're going back to the first example that we did yesterday when we were doing translations, graphing translations on the coordinate plane. And this is what, once we got it graphed, it looked like. So we're going to write down the coordinates of the pre-image figure, triangle ABC, and we'll look at the translation, and then we'll write down the new coordinates for triangle A prime, B prime, C prime. So let's start with A. We always start at the origin and we count back. Negative 1, 2, 3, 4, 5, 6, 7, negative 1. So negative 7, negative 1. And then B, negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 1, 2, 3, 4, 5. So negative 10, negative 5. And C, negative 1, 2, 3, 4, negative 1, 2, 3, 4, 5, 6, 7. So negative 4, negative 7. All right, then we have a translation of 11 units right, so positive 11, and 5 units up, so positive 5. And then we have new, or image coordinates. A prime is 1, 2, 3, 4, so positive 4, positive 1, 2, 3, 4. B prime is positive 1, 0. And C prime is positive 1, 2, 3, 4, 5, 6, 7, and negative 2. So I want you to take just a minute, pause your video, and see if you can make a connection between the original or the pre-image coordinates, the translation, and the image coordinates. All right, if you remember yesterday, another way, this 11 units right and 5 units up was our verbal rule for the translation. And this T, 11.5, was another way to show it, but we also said that you could show it as X. And since that's positive 11, X plus 11, Y plus 5. So let's see. If I add 11 to negative 7, it gives me 4. And if I add 5 to negative 1, it gives me 4. Well, let's check B, see if that works. If I add 11 to negative 10, it should give me 1. And if I add 5 to negative 5, it should give me 0. Well, let's check C. Negative 4 plus 11 should be 7. And negative 7 plus 5 should be negative 2. So it looks like all we do is add our translation to our original coordinates, or our pre-image coordinates, to get our image coordinates. So our rule for translations is to add the translation to each ordered pair. So you'll need to pause the video and write that down. Well, let's try another one to see if it works. So we have triangle A, B, C. So A is positive 1, 2, 3, positive 2. And B is 0, because we didn't move left or right, and negative 2. And C is 1, 2, 3, 4, 5, 6. So positive 6, negative 1, 2, 3, 4. And we're using the rule x minus 5y. So let's use the rule. 3 minus 5 is negative 2. And then the fact that it just says y means we're not adding or subtracting, so y stays the same. And we'll check these as soon as we get through. That would be A prime, as soon as we find our coordinates for all of them, just to make sure that that's where they are on the graph. So 0 minus 5 is negative 5, and the y does not change, so that's negative 2. And C prime would be 6 minus 5, which is 1, and the y value does not change, so negative 4. Now let's count it out. A prime, negative 1, 2, positive 2. What we got? B prime, negative 1, 2, 3, 4, 5. So negative 5, negative 2. That's what we calculated. And then C prime is 1, negative 1, 2, 3, 4. So we, without even looking at a graph, we're able to determine the coordinates of the image after the translation. So let's try some without. So we have triangle ABC with vertices A, 1, 2, B, 3, 1, and C, 3, 4. It's translated by x minus 2, y plus 1. Give the coordinates of the translated triangle, A prime, B prime, C prime. I always like to write what I'm adding. So x, I'm adding a negative 2, y, I'm adding a 1, negative 2, positive 1, negative 2, positive 1. It just makes it easier for me to see. So A prime, 1 plus negative 2 is negative 1. 2 plus 1 is 3. B prime, 3 plus negative 2, or 3 minus 2, is 1. 1 plus 1 is 2. And C prime, 3 plus negative 2, or 3 minus 2, is 1. And 4 plus 1 is 5. And to me, that's much simpler than graphing it and having to count. All right, one more example. Move this out of the way. We have triangle XYZ with vertices x, negative 4, negative 4, y, negative 3, negative 1, and z, 2, negative 2. We are translating that x plus 3, y minus 5. So we are going to do x plus 3 minus 5, plus 3 minus 5, plus 3 minus 5. So x prime, negative 4 plus 3 is negative 1, and negative 4 minus 5 is negative 9. Y prime, negative 3 plus 3 is 0. Negative 1 minus 5 is negative 6. And z prime, 2 plus 3 is 5. And negative 2 minus 5 is negative 7. And that is the end of our lesson. I will see you all tomorrow. Have a great day.